Welcome back to Meet the Partners, the interview series from the TWINGHY project. Today, we continue this series by looking at a very important technical aspect of the project. We are very pleased to welcome Thorsten Tonnesen from Aachen University.
Yes, hello, Irene. Yeah, I'm glad to be here and happy to join this interview.
Let's start with your personal presentation and your role in the project.
Yes, as you said, Thorsten Tonnesen, my name. So I've studied metallurgy and materials here at Aachen University in Germany. I'm now responsible for the working group of refractories, which is part of the chair of ceramics here in the faculty for mining and metallurgy here in Aachen. I'm responsible for many years now for the research and development in this field of high temperature ceramics, which our refractories are. And even this project shows it. There's a close relation to industrial application, of course, because refractories are directly linked to metallurgy or to metallurgical processes. And I do this now for more than 25 years already.
Your work focuses on the behavior of refractory materials under hydrogen atmospheres. For those who are not familiar with industrial furnaces, refractory materials are essential because they protect the furnace structure and allow it to operate at very high temperatures. Why it's important to study the behavior of these materials before introducing new fuels?
Since I said it, it's very close linked to metallurgy. And to be honest, the refractory material is a hidden champion. Without refractories, usually you're not able to produce other materials as well. So for the metal production, but also for many other high temperature processes, glass making, cement making, aluminium, we need refractories to contain, let's say, for these furnaces, to protect, let's say, the melt, or in this case, the steel bars, in this environment of the furnaces. Since we are operating at high temperatures in these processes, you need material which can withstand these process temperatures on one hand, but also the process conditions. And of course, due to firing and due to, let's say, the combustion, you need to enhance the temperature in these furnaces. You have on one hand the atmosphere. This is one of course main factor, which is also influencing for the steel treatment first. But also, since these refractory materials, these are high temperature ceramics, these are minerals. These materials and their raw materials, and of course their constitution, is also affected by the atmosphere which is applied. And the atmosphere is, of course, one thing is temperature, and the second is, of course, the vapor phase or the gas phase in the furnace. Since you are firing with up to now with natural gas, or even if you have other combustion gases, of course, these atmosphere influence also the lifetime of the material. We know that even all materials suffer from corrosion. Corrosion is a high temperature reaction with vapor phases, with gas phases. And therefore, it is, of course, in this case, since TWINGHY is a project where the combustion atmosphere for this reheating process of steel billets is used, to change the atmosphere. So there's hydrogen in this combustion atmosphere as an additional gas phase. And of course, at high temperatures, these materials, they have a certain reaction behavior, of course, and this needs to be, to be examined. And what is the influence to the refractory material? Because if the refractory material would show some failure or some disintegration, or it would, let's say, at the end collapse by softening or even by melting, because there is a chemical reaction, of course, then it would be a catastrophic or even a very severe action in terms of the process stability for this reheating of the steel billets.
One of the objectives of TWINGHY project is not only to demonstrate a solution in one specific furnace, but also generate knowledge that can support future industrial applications. To what extent can the findings from TWINGHY transfer to other reheating furnaces or other sectors? And what factors should be considered when assessing the compatibility of refractory materials with hydrogen atmospheres?
Okay, yes, maybe again, I take a circle to, let's say, to the impact what is the vapor phase or what is the gas phase with this hydrogen? How does it interact with the refractory? And of course, then how is the reaction with for the steel process? So, and if you consider, let's say, the transformation of other industrial processes, it's not just the steel industry who is undergoing this transformation. In energy supply, there are others. I said refractories are also used in other parts of metallurgy, but also used in other high temperature industries. As I said, the glass industry, cement, aluminium, for instance. Maybe each process has its unique composition, but of course they are similar. I mean, we use this similar raw materials for different processes, depending, let's say, on the atmosphere, but also mainly influenced by, let's say, the final temperature in these processes.
Thank you very much, Thorsten, for sharing your insight with us and for helping us to understand why materials research is so important for the safe and the reliable use of hydrogen in industrial furnaces. And to everyone watching us, thank you for joining again in this Meet the Partner series. We hope this conversation has helped you better understand the scientific work behind TWINGHY project and how we are supporting the transition towards a lower carbon steel production in Europe. If you would like to learn more about the project, you can visit our website in www.twinghy.eu.